Hey guys, welcome to Accelerated Pre-Calculus. So this is our first lesson. Our first lesson is about radians, but let me explain to you a little bit about how these videos are going to work first. So at the beginning of every lesson, there's going to be a video. The goal of these videos will be to give you short 5 to 10 minute explanations of some of the knowledge that you're going to be gaining in this lesson. These videos are not meant to be all-inclusive or comprehensive. These are meant to give you the knowledge that you need before we come into class. So in class, what we're going to do is we're going to go through any questions that you guys have about this video, and then we're going to work some more specific examples, and we're going to see some more in-depth examples of these problems. So the problems that we do in class are going to be more emblematic of the level of rigor or difficulty of questions that you're going to need to be able to solve, and here is just about giving you the basic information. So what I recommend that you guys do while you're watching this video is if you don't understand something, the first time you see it, try and go back, watch it again, see if you can really internalize it. And if not, what the second thing, B, that I'm recommending that you should do is take notes while you're watching these videos. And if there's anything you have questions about, be prepared to ask questions when we get to that lesson in class. So without any further ado, let's get started with our first lesson about radians. So a radian is actually an angle measure. So it's a way of measuring angles. So before we get into the definition of a radian, we need to talk a little bit just about angles and what they look like and some different definitions that might be different from what you saw in geometry. So first of all, a little bit of terminology. So the initial side of an angle is typically in pre-calculus is placed on the x-axis in the coordinate plane. The vertex is typically placed at the origin and the initial side is placed along the x-axis. The terminal side is the side where the angle ends. So if you notice right here, all three of these angles visually are the same. What's different is the type of rotation that results in that angle. So if we notice right here, counterclockwise rotation. So if I take from the initial side and rotate counterclockwise, I'm going in a positive angle. So that angle is going to be positive. So we're going to use degrees here. Let's just say, for the sake of this example, that this angle is about 30 degrees. So if this angle is about 30 degrees, then if we go the other way, so if I have a clockwise rotation, then it's actually going to be a negative angle. So if this angle was about 30 degrees, if I rotate clockwise, the angle is negative. In this case, that would be negative 330 degrees. Now it's negative 330 because a circle is 360 degrees. I didn't go the whole circle. I knew this was 30 degrees, so this was negative 330 degrees. So angles like this that are visually the same, but they're found by using different angle measures are called coterminal angles. So it's two angles that are visually the same, but they're created using different types of angle rotation. So then this third one is still a positive angle because I'm still rotating counterclockwise. But the difference here is I completed a full circle, which is 360 degrees plus another 30 degrees. So this angle would actually be 390 degrees. So this is just a couple different examples of ways that angles are written. Yes, it is possible for an angle to be greater than 360 degrees. If you're really into skateboarding, you might know of a trick that Tony Hawk once did called the 900. That was called the 900 because he did a 900-degree twist while he was on his skateboard. 900 degrees is 2.5 circles. So, a little bit of trivia right there for you guys. Didn't think I knew things other than math, did you? So, we're going to look a little bit more at these angles. So, this is called standard position. So, like I said, typically in pre-calculus, what we're going to see is the vertex at the origin and the initial side along the x-axis. So if an angle is in that position, it's called standard position. And again, if it opens this direction, so if it opens counterclockwise, that is a positive angle. And if it opens clockwise, that is a negative angle. All right, so we're just going to look at a quick example, give another possible measurement. So this angle was negative 90 degrees because I went clockwise 90 degrees. So one other way that I could do this is I could go counterclockwise instead. And that would be how many degrees? Good, 270 degrees. If you guys ever watch Dora the Explorer, I'm going to be doing that a lot during your videos where I just wait for you to give a response, knowing full well that I'll never hear a response from you. but I'm hoping that you're answering at home. So we can do the same kind of thing here. This one, I went counterclockwise 225 degrees. So this is a positive 225 degree angle, which would be equivalent to, what would go here? How many degrees would this be? Good, it is negative 135 degrees, because 360, full circle, minus 225 is 135. Good, so now that we have a little bit of understanding about angles, what they look like, some terminology that goes along with them, we're finally going to talk about radians. So radians are a unit of measurement of angles. So you've previously talked about degrees. You know what a degree is. There are 360 degrees in the circle. 1 degree is the amount of openness that an angle needs to cover 1/360th of a circle. So what 1 radian is the measure of a central angle required to subtend an arc equal to the radius of the circle. So what that means, as I tried to draw this arc, so what that means is, if I look right here, I have the radius of the circle, right? This is also the radius of the circle. The length of this arc will also be the same as whatever the radius of the circle is if the measure of this angle is 1 radian. So what this means is that this, let's say the radius was 3, then this arc also has a length of 3 units. So this works no matter the size of the circle, because as you learned in geometry, all circles are similar. Every single circle is similar, which means no matter how big or how small I make this circle, this amount of openness, this 1 radian for an angle, will always have an arc that is exactly equal to the radius. So again, we said that this is an angle measure, it's a way of measuring angles, and it's going to be helpful if we can use, or if we can convert between radians and degrees. So we know that a whole circle is 360 degrees. It would be helpful if we knew how many radians a full circle was, so that we could use some kind of ratio to convert back and forth between the two. So we can actually figure out how many radians are in a circle. So remember I told you that this arc has a length of 1 radius, right? Well, then if I wanted to cover the whole circle and go all the way around the outside of this circle, how many times would I need to multiply by the radius to get the whole circumference of the circle? So as it turns out, because we know what circumference is equal to, right? The circumference of a circle is equal to 2 pi times the radius. So therefore, in an entire circle, there are 2 pi radians, which means that 360 degrees, which is a whole circle, is equal to 2 pi radians. So this is very helpful because it helps us convert back and forth between degrees and radians. And I could actually kind of simplify this a little bit. And instead of saying 360 degrees, if this is 2 pi radians, then if I had pi radians would be 180 degrees. Basically, I just took this and divided by 2. So because of this fact, we can use this ratio to convert back and forth between degrees and radians. So we're going to use this to convert 30 degrees to radians. So like, let's say that I have an angle in degrees, which is 30 in this case. So I have 30 over 180 equals, we'll just call it x over pi. All right, so I need to solve for x. I need to figure out what this angle is in radians. I can simplify this to 1/6 equals x over pi. So x must be equal to pi over 6, which actually makes perfect sense, because if you think about it, we just said that 180 degrees is equal to pi radians, correct? Well, 30 is 1/6 of 180, which means this angle, x, should be 1/6 of pi, which is pi over 6. Does that make sense? If it does not, remember, we will be going over this in class. Make sure that you take down some notes. Let me know what it is that you're having trouble with. You can also, if you want to practice, if you go on to Canvas with each module, there is a practice quiz in there as well. And you can just work through some of those problems. You can do that quiz as many times as you want. And in fact, you will have to do that quiz and get at least an 80% on it in order to move on to the next unit or to the next lesson. So use those to practice. It doesn't matter how bad your grade is the first few times you do it, because you can try it as many times as you want, and Canvas will keep your highest grade out of all your attempts. So we just converted 30 degrees to radians. There are a few degree measures that you should know, being able to convert between degrees and radians by heart. In no way do I expect you to do this immediately, but by the end of this unit, you definitely need to be able to go back and forth between these different measurements. And if you look at all these measurements here, it's actually, it makes sense the way they convert, right? We already know that pi is 180 degrees. We know that 30 degrees is pi over 6 because 30 is 1/6 of 180. And I can do that same thing repeatedly. 45 degrees is 1/4 of 180, so it's pi over 4. 60 degrees is 1/3, so it's pi over 3. 90 degrees is half, so it's pi over 2. And now I can use these 4 measurements here to help me find all the rest of these measurements. 120 degrees is 2 times 60, right? So this is 2 times pi over 3, and so on and so forth. We have the same pattern repeating all the way up to 2 pi, which is 360 degrees. So we're going to go over a short example of why measuring something in radians can be useful. And one of that application is arc length. So let's say that I have a circle with a radius of 2 meters. Please forgive my terrible circle drawing, but that's the best I can do with this limited technology. So I have a 2 meter radius on the circle, and there's an arc out here, and this arc right here is subtended by this angle with a measure of 0.25 radians. So here's where the definition of radians really helps us. So remember, a radian, so 1 radian in angle measurement is equal to 1 radius, correct? Which means, an arc that is covered by 1 radian is equal to 1 radius, which means that an arc covered by 0.25 radians should be 0.25 radii, 0.25 times the radius. So if we just call this arc, I don't want to call it X, Z. That's a cursive Z, by the way. So if I take arc Z, Z is going to be equal to my radian measure, which is 0.25, times 2, because 2 is the radius of the circle. So therefore, this arc Z right here should be 0.25 times 2, which is 0.5, which is 1/2. 1/2 meters. So it's half a meter. So in general, if I want to find the arc length, if my angle is measured in radians, it's just theta, which is the measure of the angle, times the radius. All right. So thank you guys for coming this far. So let me also recap the way the end of the videos are going to work. So at the end of each video, I'm going to tell you what we went over today. So today we talked about the definition of radians. Before we did that, we talked a little bit about angles and some different terminology for angles. That was more to make sure that we were on the same page when we were talking about what these angles look like. You do need to know those words, but really our first important topic was the definition of radians. Then we talked about converting between degrees and radians. And then we also covered a little bit about arc length. So in class, we're going to talk through these things. Hopefully this video has helped you kind of gain an understanding of these things. And then we're going to talk about some different applications. So some ways that we can use radius to help us. And those 2 applications that we're going to cover are going to be sector area and circular motion. So thank you guys for watching my video. I appreciate it. And I hope that you guys took notes, learned something from this. And I will see you in class whenever we go through this topic.